Howdy, and welcome to the GasQuip SF6 gas analysis training with the Flex modular SF6 gas analyzer. Ooh, that's a mouthful. My name is Luke Benden. I'm going to give you an overview of the course that you're about to take and an overview of GasQuip really quick before we get started. So GasQuip has been around for about 5 years. We've quickly grown to a multinational company selling in many different countries around the world. And we have been recognized for our fast growth rate, made the Inc. 5000 this year for top 5,000 fastest growing companies. So beyond that, we make gas analysis equipment, leak detectors, mass measurement devices, and adapter kits, really anything to do with moving gas in and out of equipment, checking for leaks, or transmitting the gas to and from different places is what we handle primarily. So on the course side, we're going to talk about SF6 contaminants and limits and what to expect while testing. We're going to get into the equipment setup and overview for the Flex, talk about how to operate the Flex, some of the settings to look out for, the maintenance and calibration of the Flex and other similar analyzers, some typical troubleshooting methods that you can try, and transportation and storage. Now, this training will be unique to the Flex, but it should apply broadly speaking to many different analyzers that are out in the field today. Why do we test SF6 gas? Let's talk about that. The answer to this question is not because my boss said so. Although your boss may love to hear that, that is not really the reason. The real reason is for preventative maintenance and safety. So for preventative maintenance, the engineers that design the equipment that we will be testing, whether it's a circuit breaker or switchgear, gas insulated bus, they have set limits associated with contaminants or purity limits that need to be met in order to maintain the life of the equipment and realize the return on investment that you made in that equipment. So much smarter people than us, the engineers, the people who set the standards with the IEC, set these standards for a reason, and that is why we're measuring these individual values to get a picture of the health of the breaker and to extend its life ultimately. And the other thing is safety. So on the internals of this breaker that's shown here, there's a lot of heat generated, and that heat, whenever it's mixed with SF6 and moisture and other contaminants, it can kind of create a petri dish of other arc byproducts that can be produced by the system. So for the operator that's testing the gas, we need to be aware that there are types of arc byproducts that can be produced that are very harmful and toxic to operators and should not be breathed in. And so if you're testing the gas, that'll give you a good picture of what the gas actually is made up of and whether or not it's safe to handle if you're pulling the gas in and out of the breaker. Why do we test for H2O or dew point or moisture? Well, there's one main reason and then there's a minor reason also. The main reason is that H2O or moisture is a fuel source for arc byproducts. So what that means is when you take sulfur hexafluoride, you take water, H2O, and then you mix that with a high heat or high energy event, you can spit off some nasty acidic compounds that are very dangerous for the operator and then also for the equipment and its long-term health. And we'll talk about some of those arc byproducts in a second, but the other main reason or minor reason is that H2O can impact the insulator's performance at high levels of moisture, generally above 1,000 ppmv of moisture. So those are the two main reasons that we actually test for dew point or ppmv if you're using that of moisture. Why do we test for SO2 or sulfur dioxide? Well, again, there's two main reasons to this. One is that it is very acidic and corrosive to the equipment that it is installed in, and also there is a lot of health risks to the operators. If an equipment does have SO2 or measured amounts of SO2 inside of it, it also likely has other harmful acids and other compounds that are produced by the stuff that we talked about earlier with the high energy heat and H2O and SF6. SO2 is more of just a leading indicator that there is a lot of arc byproducts present, and it'll cause issues for the equipment and also the operators. Let's talk test limits and start with SF6 gas purity. For SF6, we've got two test limits that we'll talk about from the IEC recommendations. The first one being for reuse SF6, you have to be above 97%. That's from the IEC 6480. Now, reuse is defined as reclaimed gas that's going to be reused either in the same gas insulated equipment or different equipment. So for new bottles or virgin SF6, the percent threshold that IEC sets is 98.5%. Now, if you're testing in-service breakers, we recommend going with whatever the breaker manufacturer lists as the threshold. That's generally safe or the best bet for dealing with in-service breakers. When it comes to the test limits for moisture or H2O, we're dealing with two main ones. The first one being the IEC recommendation for reused gas or gas that has been recovered from an SF6 breaker and then filtered out and then ready for reuse is going to be below 200 ppmv, and that is the IEC 6480 regulation or recommendation. On new bottles, it's also below 200 ppmv. Now, if you're measuring at the breaker or at the equipment, always use the manufactured guidelines for that specific equipment. The test limits for SO2 are also based on the reuse and new gas. So for the reuse, it needs to be below 12 ppmv, and for new bottles of gas, it needs to be below 7 ppmv. As a side note, if you do have gas that tests some level of SO2 in it, I would recommend flushing out your analyzer with nitrogen. It's a good way to flush out all of the sticky SO2 that can kind of build up and the other acidic components that can build up in that gas. If you don't have nitrogen, you can run some tests of SF6 and then pump that into an empty cylinder. We will touch on this later, but I want to show you right now what it looks like to use the test limits inside our Flex analyzer. So let's go to the close-up view. If you go to settings and then go to test limits, we have preloaded the different IEC recommendations for new and reuse SF6 that we just covered. So you can easily click those and it'll apply to the test that you run. When you open up your Flex Analyzer, in the top lid, we have organizational pouches. Here in the top, we have our torque wrench and USB stick, and you'll also find your manual and your calibration certificates. And there's calibration certificates for each individual module. And over here, we have our sampling hose and our power cord for our Flex. And that's all that'll be in the top lid. Let's talk about the mechanical overview of the Flex on what we're looking at here. Starting down here in the bottom left, we have some common adapter fittings that are included with the Flex. This is a DN20 female by Rectus Type 21 quick disconnect. Similar idea here with the DN8 female by Rectus Type 21. Moving on, we have the modules. So there's a module manifold that sits underneath here. Any module can be installed in any of the 9 positions on the module manifold. The empty modules that you see here that aren't labeled are just blanks. They're empty to protect the underlying manifold. And then obviously the sensors are labeled with which contaminant or gas that they're measuring here on each of the sensor modules. Down here we have the sample hose port that our sample hose will connect to. So that's a male going into the female. Across from that is the auxiliary storage port for connecting up a gas recovery bag or a external cylinder, so just auxiliary storage. Up here we have some communication ports that aren't really going to be used by the user out in the field. That's more for advanced troubleshooting back at our shop. And we have a USB port that is for the USB storage stick for upgrading your firmware. You can also plug in a mouse for controlling the display with a mouse. We have our power connection and then our power button. And then over here on the left, we have our gas recovery bag that sits underneath this panel. Next to the gas recovery bag, there's a panel that sits right here that has a fuse, and we'll get into that once we talk about the maintenance section. But as far as the mechanical overview goes, that is the layout of the Flex. The touchscreen interface on the Flex is pretty straightforward, so let's get into what you're looking at here on the touchscreen. When you boot it up, this will be the default screen that the Flex loads to. Over here on the right, you have your time, you have the input pressure, and you can change the units of the PSIG that is defaulted to here. This dynamically will fill up as you apply pressure. Same idea with storage. This will fill up and give you a readout of the storage percent. Below that is an auxiliary storage toggle button, which you can toggle on and off if you have auxiliary storage hooked up like a gas recovery bag. Below that is the play button for starting a test. And in the middle here, we have rows of sensor modules that are connected. In order to select and deselect a sensor for a test, you literally just select and deselect it. And you can scroll down and see which ones you'd like to scroll. Up here we have the functions of the different functions that are included with the Flex, and then one down here. Down here in the bottom middle, we have a readout area that'll read out things like calibrations being overdue or errors that the system might have ran into. So that's more of an information field area. In the settings, we have system settings. We have our log area for logged files from different tests. A user login screen. The modules, which shows the calibration date, expiration date, the version and serial number. And then our test limits, which we can choose from different preloaded test limits that we have preloaded for you, and you can also save new ones. So we'll get into all the individual settings and features here in a little bit, but as far as the interface is concerned, that's where everything is laid out. Now we're ready to run an actual test. So I've got a pure bottle of SF6 over there, and I've got our sample hose down here. The first step is going to be attach your sample hose to your analyzer and pull an evacuation on the hose in order to get rid of any prior tests or sample of gas that was in there before we started. So we'll take our male end of our hose and connect it to the female sample hose port and pull back the collar and then connect up, and you'll hear it click when it's connected. If we go back to our analyzer close up, you see that our input pressure is 0.18 psi up here, PSIG. We're going to run an evac hose. It's going to ask us, are you sure you want to evacuate your hose? Please confirm that there is no vessel connected, or you will pump all your gas to your atmosphere. So we don't want to do that. We have nothing hooked up to the other end of the hose. So we'll click yes, and then the hose evacuation is going to run. So you'll hear the pump kick on for a few seconds, and then the system is going to check that hose for leaks once the actual evacuation has pulled on it. So it's checking to see if the vacuum is rising back to 0 psi or towards 0 psi to see if there is a leak. And if it is not, then it'll give you a pass. And if it does rise too much during that amount of time, then it'll fail the test, and you'll have to either retry the test, or if you fail again, you might have a leak on your hose. Now we can see that our input pressure is negative 12.64 PSIG, so we have a good vacuum on our hose. Seems like it's holding, and we can run a test. Our storage amount here, we've already run one test this week, so our storage is at 25%. That's plenty enough storage left over to continue to run more tests. Depending on what we actually want to test for, we can check and uncheck those sensors to be used during the test. I'll leave O2 deselected right now so we can just run a standard 3-parameter test on this gas bottle. So let me go back to our scene. So we have our gas cylinder over here. What we're gonna do is open our gas cylinder up, and you'll see that we get pressure on the high side gauge. We'll open that all the way up. Now we want to get pressure on our low side gauge, so we'll screw our regulator knob clockwise until you start to get pressure. Doing a test on the cylinder, the pressure doesn't matter all that much. I usually set it to around 20 to 30 psi just so it's easier to work with. We'll take our female side of our hose, and we're going to connect it up to the male side here on our regulator. You'll click it in, and you'll hear the gas is starting to flow through the hose. Now that we have that done, we can actually run the test. So if we go back to our analyzer close-up, all we have to do is press the play button, and the test will start to run. So while that's running, I can talk about a couple different things here. The first test of the day always runs for 12 minutes. The reason for that is that the H2O sensor runs a heater for 5 minutes on the first test of the day, or anything that is within the last 24 hours, it'll reset that timer. So that H2O sensor will heat up for 5 minutes prior to testing. The reason it does that is to help burn off some of the residual moisture that creeps into the device or might be left over from previous tests. So that heater will run, try to burn off some of that so that you get a good result on the first test. Any subsequent test that you run will run for about 7 minutes as opposed to 12 on the first. So as this SO2 sensor runs here, we can see that we have a loading bar to show us how much time is left on the SO2 test. Below that, you have the 0.0 ppmv is the reading. And then here in parentheses, we have listed as the accuracy of the sensor. So this is a 0 to 500 ppmv range sensor, and the accuracy is plus or minus 2%, which translates to our plus or minus 10 ppmv. Up here at the top, we can enable auto pump back or disable auto pump back. So if you see disable, then that means it's enabled, or you can toggle it off. What that does is it runs the pump back feature in the background as the results are showing, and it's just helpful to save time. We can still see our input pressure and storage pressure and how those will change over time as we run the test. Our toggle units down here, we can toggle the units of our H2O sensor. And of course, we still have the remaining time down here. At any time, we can cancel the test by pressing the pause button. All that does is just cancel the test. It'll keep the storage percent gas that you are currently up to at the test the same. If you go back to the home screen, it'll be the same, and you can keep going from there. If you have more than 3 modules installed, you'll have to click into this and scroll down. We can see that our O2 sensor module is disabled currently, so that'll just show disabled. And now we can let these SF6 and H2O modules warm up for this first test of the day. As our SF6 and H2O tests run, we can point out here the live readings. So we have 92.3%, which should continue to rise as we test this pure bottle of gas. The accuracy is listed as plus or minus 0.5%. That comes directly from the sensor. And then of course for our H2O sensor, we have a reading of 49 ppmv, which again can be toggled to a different unit by hitting this button. The accuracy is given in terms of plus or minus 3 degrees C, which is a default value from the maker or the manufacturer of the sensor. Those accuracy measurements are given in terms of degrees C. So we list those on there as another piece of information. Now that our test is fully complete, we can take a look at the results. Yes, I do have a different polo on. It is the next day. So let's take a look at our results page. Here on the top, we have the name of the test. So you have the date and time, followed by the serial number of the flex and a .log. You can change that by clicking rename and then add in whatever you'd like up top here, and that'll change the name. In the right-hand corner, we have the username that you can add, the location, and then the additional notes. So I'm just clicking into these areas, and we can add in any additional notes here to the notes section. So I'll just put notes so we have a placeholder. On the left-hand side, we have the same layout as before on the home screen. Up here in the top left is the units. We have the module that you're reading, and then the actual reading here, so 0.0 ppmv of SO2 with the accuracy of the sensor, and then the threshold or test limits that we set earlier and whether or not that test limit has passed. For H2O, you can click on the module and it'll toggle the units of the test. So that's helpful if you need to just check how that converts to a different unit. I'm going to go ahead and save this, and it's going to say log successfully saved. Would you like to pump back? Since we are dealing with a regulator, we cannot pump the gas back through our regulator for two reasons. One being that our regulator has a check valve, and the second being that our regulator, or our actual gas cylinder, is too high pressure, so you can only pump back into a gas reservoir or a cylinder that is below 150 psi, because that's what the internal pump can handle. So we won't be able to pump back into our bottle, so we'll say no for now. And you'll see that our storage has increased. We want to go ahead and export this log file. So we'll find the file that has the name that we just gave it, this AAA file, and we're going to select all to unselect everything, and then we're going to click this check mark. Now what we're going to do is plug in our USB stick and then hit export. So I have a mouse USB toggle here that I have to unplug. I'll plug in our USB stick. I'm going to let that load just for a second for it to recognize the system or the actual USB stick in the system. Since we have our file checked here, we're going to hit export down here in the bottom left, which is right there. And it's going to tell us one file successfully exported, and then we can take a look on the Excel file what the actual data fields that are exported onto that .csv file actually look like. Once we have our USB stick hooked up into our laptop, here's what that file will look like. So the name of the file that we renamed it to initially will pop up as the file name, and you can open this up in Excel or a similar program. Let's make this adjusted. So we have the test name, the flex serial number that you ran it on, date, time, the user and location data that we left blank ultimately in ours, the note section, and then you have the raw readings from each of the individual sensors, along with the pressure sensor on the input and the start, and then also the end pressure input from the test. Let's talk about some of the special functions that we have that are found on the home screen and when to use them. So up here in the top left, the pump back function takes all of the storage found in the internal of the device, and also if anything's hooked up to auxiliary storage, it'll pump all of that gas back into the gas reservoir that you're testing. So you can use that straight from the home screen or also after a test is finished. You can also do an evac hose here from the home screen like we did earlier, and that's going to pull an evacuation on the hose or any fittings or any regulators that are hooked up to the end of your sample hose. We can run an evacuation of bag if you've run a flush system with nitrogen, just to flush out your system with like pure nitrogen, or if it's appropriate to do so with SF6, you can evacuate all of the internal storage to atmosphere. Your leak check function is going to pull a evacuation on all of the modules. So evacuation gets pulled on all the installed modules and all the plumbing that runs from the pump to the modules. And it's going to hold that for 10 to 15 seconds, much like the leak check on the evacuation of hose function. It's going to pull evacuation, watch for a rise in pressure, and if it doesn't see that rise, then it'll pass the test. And if it does, then it'll tell you that you have a leak, and it'll actually tell you which module position that you have the leak in. So very helpful to troubleshoot. Down here we have a dry system function. What this does is pulls an evacuation on all of our modules and also our inlet fittings and connections. So all the internal plumbing plus the module manifold, pulls an evacuation on those and holds it and runs that for about 5 minutes. That way it can help burn off some of that residual moisture, and also runs the heated tip on the H2O sensor, which helps burn off some of the residual moisture that might be found in your system. You want to run that function if you have had your analyzer sitting out for a long time, or you would want to run that dry system function if you've had your analyzer sitting on the shelf for a long time and you haven't had dry gas running through it for a while, or also if your tests that you're getting are showing a much higher moisture reading result than you would have anticipated. That can also help kind of lower the results down to a dryness that you would have otherwise anticipated. And that'll run for about 5 minutes. Let's talk about how to use auxiliary storage. So we sell a gas recovery bag that looks just like this. So this is our standard size bag. It comes with another braided hose. What you're gonna do is plug your male end of your hose into your bag here, and then the female end of the hose is going to connect to our analyzer here on the front, like that. And what we do on the main screen is go back to our analyzer close-up here. We're gonna click auxiliary storage, and you'll see that our storage now has changed to accommodate the extra auxiliary storage. So that's telling the system that we have now an extra 52 liters of storage that we can store gas in. If we're using a different gas recovery bag, oops, yeah, I need to change this. So we need to go back to 52 liters, and that'll tell the system that we're adding a 52 liters amount of storage. If we had to disconnect it for whatever reason, just uncheck that and it tells the system that we're going back to just what's installed inside of the Flex. Now, if you do have auxiliary storage hooked up like our gas recovery bag, you can expect to get an extra 20 to 25 extra measurements if you're running SO2, SF6, and H2O all together. The reason that most people will use a gas recovery bag is so that you don't have to run the pump back feature so often and empty your device, because the average Flex unit can hold 2 to 3 samples at a time with the internal storage. But if you use the gas recovery bag, you don't have to run those pump back functions so often. So you can test a whole row of breakers or bottles or whatever it is, and have that extra storage. So let's talk about a few general tips when it comes to testing that should help you get a better experience out of your analyzer, any analyzer for that matter. I would recommend always having a dry regulator that you keep in a dry box or area that you can always hook up for testing on a bottle. And also try to always use fittings that are the shortest amount of fittings together that you can. I've seen a lot of times where guys are using these Frankenstein type fittings where they have this adapter on top of this adapter on top of this adapter with sealants and PTFE tape, and it's just a long piece pipe looking Frankenstein adapter that is not good for testing, because it introduces more and more areas for leaks and points of entry for ambient air to get into your sample. Also, if you are testing a gas breaker, If you pump back into that gas breaker, you can expect for your moisture results to be a lot higher on any subsequent tests. You have to allow the gas to re-homogenize inside the breaker for at least 24 hours if you want to get a good representative result from that breaker again. So testing gas, test 1, 2 tests, but if you pump back into that breaker, you're not going to get a good reading on your moisture. It's going to be skewed higher than it actually is inside the breaker. Also, it is very normal for, if you're testing a bottle of gas, to have the first test a little bit wetter than you're expecting, and then subsequent tests to dry out. The reason for that is the dry gas that's running through the hose, the fittings, the regulator, the analyzer is drying out that gas path along with the tip of the sensor. And if you're running a few more tests on top of the first test, it tends to show a drier and drier result. We'll get into some of the more troubleshooting things later, but that's what you should expect to see if you are testing on a bottle or a dry breaker as well. As far as material compatibility goes, always use a PTFE or Teflon style lined hose like the one that we provide, the stainless steel braided hose, and stainless steel fittings, brass fittings, and avoid using rubber anywhere in the gas path for the sample because rubber tends to hold on to moisture. It absorbs and adsorbs moisture into the sample. And also avoid using any PTFE sealant. So the goop or Loctite type sealant, avoid using that. Always use PTFE tape. The reason for that is that the PTFE sealant can gunk up the sensors and off gas into the sensors in the system over time. So try to avoid anything that can off gas any type of VOCs or any type of materials into the system to keep everything clean and nice and fresh. Going into system settings, we'll click on the gear icon here at the top left, go into system. And the first, working from top to bottom, is auxiliary storage capacity. So if we click into this box, we can set a new capacity for our auxiliary storage capacity. We default ours to 52 liters because that is the size of our gas recovery bag that we sell, but you can change that. Date and time, if you click into the individual boxes, you can change the date and time, and then also toggle our AM, PM to whatever you need. The displayed units for H2O sensor temperature can be toggled just by clicking to the box. It's defaulted to degrees C. Our pressure on our input pressure on the home screen, you can toggle this to whatever you need. And then same thing with the H2O module readout, it can be changed here. And then also while a test is running and on the log test screen as well. The gas type / mixture tells the system what type of mixture that you are testing. So if you're testing, a 60-40 gas mixture of SF6 CF4, you go back to your home screen and that will affect the readout here to tell the system that you're testing that mixture. And depending on what you are actually testing, so let's go back to SF6, it will select or deselect certain modules by default. So for example, now our oxygen sensor is deselected because we won't be using that sensor for testing either pure SF6 or SF6 on a gas insulated system. Going below that, we have the language toggle that you can toggle. Once we have more languages to update, we'll have that updated in that area. A system reset, which can be run, which resets any of the log files and resets all of the settings back to default. The update screen, so if you have a firmware update that needs to be run, you click on this and then plug in your USB stick. We'll get into the nitty-gritty of the details on that later on. But as far as system settings goes, the only thing left is down here the serial number. This is the serial number of the Flex, the overall unit, and then the firmware version of the Flex that's currently running, and then of course our brightness. To access our module settings and information, we're going to go over to our gear icon here in the top left. We'll go over to modules, and click on the individual module that you would like to get information from. Here we have the original calibration date of the module, the calibration expiration date, the version number, and also the serial number of the individual module. The individual serial number is also printed on the module itself on the side of the black casing. But this date, this calibration expiration date, is what tells the system that the module is overdue. It won't lock you out of running a test. It's just there to remind you that it needs to be replaced. Let's take a look at our test limits and test limit settings. And first, before we go into the settings, I want to show you what it looks like to actually have some test limits. So this is a test we ran before. Down here below, we have the individual sensor readouts. These areas down here, let me blow this up for us, where it says below 7 ppmv, that is our set test limit that corresponds to whatever we set in the settings. So for example, for SO2, our readout was 0.0 ppmv, and that is below 7 ppmv. So our whole module area right here turns green, and we get the green check mark. Same thing for SF6, our test limit was set to 98.5%. So our actual reading was 99.9%. Therefore, we are above our test limit threshold, and our sensor readout here turned green. Same thing for H2O. We're below 200 ppmv, and our readout read 75 ppmv. So the whole thing turned green and is a check mark. Test limits are meant to just be a reference for the user to determine whether or not that test that they ran met the criteria, whatever the criteria may be, that they need to see. So if we go back to our settings by going to the main settings and going to test limits, let me blow this up again, we can see that we have some defaulted values here for each of the individual sensors. So like, for example, here we have a max test limit for SO2 because we don't need a minimum amount because that's a contaminant. So we have a max of 12 ppmv, and that is a default that we send with the unit. The minimum is 97%, and if we toggle this to N2 or CF4, then we can also set the test limit minimum for SF6 for those individual mixtures. So if you had a mixture of SF6 and nitrogen, you can set this to whatever you want. And then you can also save a new value, and I can show you what that looks like. So say our internal policy is that nothing can be below or above 8 ppmv on SO2. We can then save that new preset for whatever we'd like. Save it. So now we have a new saved value test limit that's different than what we have as our default values. We have some preloaded values here for new SF6 based on the IEC rating for that, and then also the reuse SF6, which actually corresponds to our defaulted values as well. It's the same thing. This is just in terms of dew point at degrees C atmosphere, and this is in terms of ppmv. If we need to delete one of our test limits that we've created, simply click on it and then click delete, and it will remove it from our list. There is two different ways to check the calibration status of your individual modules. The first is to look at your calibration reports for each of the modules, and you just pull that out and look at that, and we can look at the close-up of it. So here on the calibration certificate, you would look at the calibration date and the calibration due date there. And also we can go into our settings here in the top left and go to modules. Click in on any of the individual modules, and you're looking at the calibration date and the calibration expiration date. Again, on the front screen, on the very bottom, if you do have a module that's out of calibration, you will get a system message down here to let you know which module is out of calibration. And also, the standard intervals for the current generation modules are SF6 is every 2 years to replace, and the SO2 and H2O modules are every 1 year. When a module's calibration interval is up and it's time to replace it, we will send you the replacement module. All you have to do is take your torque wrench that's provided with the unit, and right now we can do the H2O module swap here. So you're gonna unscrew either side of these bolts on the module using the torque wrench. And what we're gonna do is we're gonna pull up from the bolts on either side to pull the module out. So you're pulling up by the bolts. Pull that up and it should click right out. So we'll grab our other module, our new replacement module, serial number on the side here to let you know. And if we take a look at our analyzer, it'll show that we no longer have a H2O module plugged in, and it'll pop up automatically once we install the new one. So to install the new one, we have just to push this down, and once you get it in position, you push it down and it'll click in, almost like an old Atari cartridge. And you're gonna tighten down both bolts. We're gonna use our preset torque wrench, and we're gonna screw either side down until we hear a click. That lets us know we're at the right torque setting and compresses the bottom O-rings at the right amount. And you get a click whenever that's done, and you're good to go. Going back to the analyzer close-up, we now see our H2O sensor installed here, and it automatically shows up and shows up in our module settings with the correct information. If you're able to, you can share your email address with us. We have an automated system that we put together that will send you a notification about a month before each of the individual modules is due for calibration or calibrated module replacement. And it'll send you one on the day that is actually due. And it will also include a pre-generated quote to make this process very simple to keep your analyzer up to date and calibrated. Let's talk about troubleshooting, which in my opinion is one of the most important things to understand when using an analyzer to fix problems that you might run into. The first category would be visual bugs. So if we take a look at the close-up of the analyzer, you might end up getting some error messages down here in the bottom. They might have a code associated with them that you don't understand or something that you didn't expect to see. The first thing that I would do is turn your analyzer on and off, wait about 5 to 10 seconds, and then turn it back on. If you don't see those issues anymore, then you might have cleared the cache of the system and it might be fine. If that doesn't work, you can also run a system reset. So if we go back to the close-up here, we'll go to System Settings and then go to System Reset. What that's going to do is delete all the logs and reset all the settings to default, and also kind of clear the back-end cache of the system to help eliminate some of the issues that you might be seeing. If you're having trouble getting your unit powered on and showing a display on the touchscreen interface, first thing I would do is turn off the power, pressing this power button. Wait about 5 to 10 seconds, let those capacitors inside and the power supply kind of regenerate and get some power to them, and then try pressing the power button again to boot up, restart the boot sequence on the unit. Always check your actual plug. Make sure it's plugged in all the way at the unit and also the wall. The power source needs to be 120 to 240 VAC if you're going to get that unit on, so anything that is outside that range is not going to be able to power the Flex. If you have no luck with those troubleshooting things, take off the panel here like I'll do now. There is an access panel that sits vertical on this side near the bag, and there is a small fuse that sits back here. It's a little green fuse. You can pull that out and check to make sure that that 30 amp fuse is intact and it is installed correctly. If it is, you want to go ahead and reinstall it and then try to power the unit back on. Now let's talk about troubleshooting your test measurements for getting results that you don't expect or didn't expect to get. The two that are most common would be getting an H2O reading that is higher than expected, so wetter gas than you expected to test, or an SF6 purity reading that is lower than you were expecting to get. The very first thing that I would do is make sure that your sensor modules are properly screwed in with your torque wrench. You're gonna install that on either side of the screws and make sure that those are tightened down to spec. And that's the first step. Second step would be make sure you have at least 5 PSI showing on the home screen for the input pressure, and that you have good flow. Your hose could be kinked up. You could have a valve closed upstream on the breaker or something like that, where the pressure starts out with enough pressure in the hose, but as that gas travels into the analyzer, the pressure drops below the 5 PSI minimum pressure, and then it'll trip the flex to stop the test because you don't have enough flow. That would be the second thing. Third thing is to make sure you don't have any rubber or any bad connections on the system or on the hose connections itself. We talked about this earlier, but rubber adsorbs and absorbs moisture and can spike your moisture levels. So if you have any rubber, I would take any of that out of the system that you're testing, and also eliminate as many of the connection points as possible, which would bring us to the third option for troubleshooting, is to employ a leak detector. What I would like to do is run our leak detector along the length of the hose, starting at the connection point at the breaker or at the gas cylinder, and just sweeping across slowly the length of the hose and the regulator, and also our connections here at the front, starting with the input fitting, and then also kind of testing around the modules and making sure that there's no leaks there. Now, the fourth way would be to do a leak check on the system itself. So if we go back to the analyzer close up, we can run a leak check. And again, that's going to pull a vacuum on all of our modules and our module manifold here, and then check to see that those are holding a proper vacuum. The fifth way that I would check is to pull off the panel and run a test as normal, but visually inspect the bag. As you run a test, this bag should inflate with gas if you have a good enough flow. So if your test is showing a really low SF6 purity and basically a maxed out value on your H2O, which if you toggle through the units would be 0 degrees Celsius at atmosphere. So if you're seeing that, it's likely, or it could be likely, that you are dealing with a low flow situation where you have issue with not enough flow, therefore not enough gas going past the sensors, so they're spiking in the wrong direction of what you would like to see. So visually inspect the bag to make sure that it's inflating with gas and not staying vacuum down in its vacuum down state after a pump back or an evac bag. It'll be really taut and tight, but you should see that to start to inflate as a actual sample is being run. If you don't see that, the sample is not being run through the system. The next thing that I would do is run a dry system. So let's go back to our analyzer close up. That's going to be down here in this bottom left. That's going to pull a vacuum on all of our major components on the system for about 5 minutes and try to help burn off and boil off some of that residual moisture that could be hanging around. This is more for the dry system, more for the spikes in moisture that you can see. So it's going to run the heated tip on the H2O sensor and also run the pump inside to evacuate any of the residual moisture that's inside of there for about 5 minutes. And that should help start you out of the clean slate to then do new tests. The sixth way that I would try to troubleshoot stuff like this is to swap your modules into a different slot. So it could be a situation where someone dropped the unit on the side and there's sensitive solenoids that sit alongside this module manifold that could have been damaged. So each individual module slot has its own solenoid. So you can swap those modules into any of the 9 module slots to test if it's working better on one over the other, which could be because of damage. If you are still getting a result that you did not expect to see, whether it's high moisture or low purity in most cases, then I would reach out to us directly to help do some troubleshooting over the phone. We have some ways to do it, some advanced troubleshooting through the unit. And also we can send you loaner modules so that you have something to go do your testing with. If you do have SO2 that is showing a higher result than you expect, this could be because you tested sulfur dioxide at some point and it got stuck to the tip of the sensor. SO2 is very sticky and tends to hang out in the plumbing and on the sensor tips. It's just the nature of the beast. So what I would do is run a system flush, basically running a test on nitrogen. If you don't have nitrogen, you can use pure SF6 to flush out all of the individual piping and modules with really dry, clean gas. Probably run 3 to 4 tests with that and then see if you still are getting a reading of SO2 that you're not expecting to see. The other way that you can troubleshoot an analyzer is to compare an analyzer with another analyzer. So here we have a T-piece hooked up to a regulator and a brand new bottle, and we're gonna run tests simultaneously off the same gas sample to compare the different results from the analyzers. This is a great way to compare also our analyzer with other analyzers to see, which one you like the best. Hopefully it's the Flex. If you're going to be transporting or shipping your analyzer anywhere, especially using UPS or FedEx, you always want to put it in a protective box, either like the one that we sell or the one that it comes in the cardboard box with the clamshell foam pieces. Anytime you ship the analyzer or any test equipment, you should know this, that UPS, FedEx, DHL, they're going to beat the snot out of it and basically break anything that you ship. So never just send the analyzer by itself in its case. They will damage it to all get out. So